Welcome back. We're going to start this next video with an investigation. We're looking at the formula for the general term of a geometric sequence. I'm going to pause here, work through the investigation myself, and as usual, I'm going to encourage you to work through it on your own as well. All right, welcome back. We're just looking at this investigation here. When we are working through this investigation, we had a sequence here where we started with a mass of 8 on day 1, and then this thing was growing by a factor of 1.5 each day, and so the common ratio would be 1.5. What we were meant to discover was, since we're multiplying by 1.5 for each additional day, as we increase the number of days, we're timesing by that common ratio an extra time. So how that looks on day 4 is you're timing the value of A, that first term, by 1.5 3 times. On day 5, you're timesing that initial day's mass by 1.5 4 times. So we're always timesing it by the common ratio, the amount of, or the term number minus 1. And so that's what we have here. This general term has the term is equal to the first term times the common ratio to an exponent of the term number minus 1. So that's what we have here, and that's ultimately what we're given here. Now, most of the terminology is the same as with the previous formulas. A is the first term, Tn is the general term, or the value of the term. R now is the common ratio, and N is the position of the term, or the term number. So that brings us to the third class example, where we're asked to determine the formula for the general term and then calculate the indicated term for each of the following. So we're going to start by writing out the general term and then solving for the term number indicated. So for this one, the first term is equal to 5, as you can see, and the common ratio, we're going to have to multiply by 3. So 15 divided by 5 is 3, 45 divided by 15 is 3, so the common ratio is 3. If we want to know T9, we're going to I'm going to just write out the formula to start with. Tn equals AR to the n minus 1. So T9 is equal to 5 times 3 to the term number is 9 minus 1. So then term 9, we're going to put this in our calculator. We have 3 to the exponent 8 times 5. So that works out to a big honkin' number, 32,805. So you can see with a geometric sequence, it really grows fast. Okay, so let's take a look at this next one. In this one, we, again, the first term is just copy down the very first term we see. Then we need to figure out the common ratio. I'm going to divide 1/6 by 1/3, and I get negative 1/2. And I can test out to make sure I'm correct and divide 1/12 by negative 1/6. Again, I would get negative 1/2. So I'm going to write the general term here. And then I'm going to calculate a T7. A is 1/3, R is negative 1/2, and then 7 minus 1 is the exponent. So I can solve that on my calculator. I have negative 1/2 to the exponent 6 times 1/3, and then put it in fraction form. I get 1 over 192. All right. So let's look at class example number 4 now. Janice and Gary, it's my aunt and uncle's name, how fancy. We're trying to determine the number of terms in the sequence, 32, 64, 128, and then finally 16384. We're asked to use the general term formula to write and simplify equation that we could use to determine the number of terms. Okay, so what we definitely need to do is we need to know our values for A, R. We're going to need to know what T of n is and n. So what we're trying to find is the number of terms. We know the value for Tn, and we can figure out the value of the first term, and the common ratio we'll find by going 64 divided by 32 is 2. 128 divided by 64 is also 2. So I have all of those terms figured out. So now what I'm going to do is I'm going to substitute the values I know into that formula. So I know that T of n is 16384. I know that A is 32. I know that R is 2. And I'm solving for n. Okay, so I'm going to try to simplify this. 16384 divided by 32 would give me 512. Okay, so I have 2 to the exponent of n minus 1 is equal to 512. Okay, so I have a formula, and with what you know about math in Math 20, you don't necessarily know how you're going to solve that. The good news, or for your information, when you're in Math 30, you're going to learn how to solve equations like this, but not yet. So in Part B, Jan decides to use a guess and checks procedure. So she could try different values and see if she ends up getting 512. So if we put in, for example, 2 to the exponent 8, we get 256. So 8 is not a big enough number for n minus 1. But if we have 2 to the 9, we end up with 512, which is what we're trying to get. So 2 to the 9 is equal to 512, which is equal to 2 to the n minus 1. So what we can assume is that 9 is equal to n minus 1, and so n is equal to 10. So we can assume that our this number is the 10th term, or that there are 10 terms in the sequence. All right, Gary uses another strategy. He's going to use the graphing feature on his graphic calculator. So he's going to use the intersect feature. So the left side of the equation, he's going to put in y1, and the right side of the equation, he's going to put in for y2. So I have 2 to the exponent of x minus 1. Now I'm going to graph it right away, but because I'm dealing with numbers that are so high, I'm not actually able to see that first line yet. So I'm going to change the values of my window, mainly focusing on getting my y values really big because I need my y maximum to include this line that's at 512. So I'm going to make y max equal to 550. I'm going to graph it. So there's my first line at 512. There's my second line. So what I'm going to do is I'm going to find the x value of that intersect. So second trace intersect I'm going to press enter. I don't know, I like to be closer to the enter. Enter, enter, enter. Why is it disagreeing with me here? Oh, okay, I apologize for that. I realized that when I was solving, I didn't have the graphing calculator where I could see it, because my light is kind of making it hard to see the, there we go, that's a little better. Okay, so I'm going to start that over. So second, trace, intersect, enter, enter, enter. And so the value of x at the intersect is 10. So I'm going to just write that out. So the intersect has an x value that's 10. So there are 10 terms. All right, so that's two different ways you can solve it. And like I said, in Math 30, you're going to be learning a system called logarithms that will allow you to solve that even more efficiently. All right, so our last page here has 3 more class examples. This one is talking about geometric means. Remember, this was had to do with points in between 2 points that you are given. So in class example 5, we have a term, 81, and then we're asked to insert 4 terms in between that and this term, which is 1 over 729. So how that would look is we'd have 81 and then 4 unknown terms at this point, and then 1 over 729. So we do not know what the common ratio is, and we're going to have to use some problem solving skills to figure out what it is. Okay, what I do know here is that I'm going to set that as my first term, so it's 81. And I am going to 1, 2, 3, 4, 5, 6 assume that term 6 is equal to 1 over 729. So I have the term number as well, that is 6. So I have 3 pieces of information, and my unknown in this case is going to be the common ratio. So I can use these 3 bits of information in the formula to find the unknown value. So I'm going to write the formula. Tn equals a times r to the n minus 1. And Tn is 1 over 729. A is 81. R is what I'm trying to find. And n is 6, so n minus 1 is 5. So now I should be able to solve this. I'm going to start by dividing both sides by 81. So I end up with r to the 5 equals a really small number, 1 over 59,049. Okay, now if I want to find r, I'm going to need to take and find the 5th root of this value. So I'm going to be finding the 5th root of 1 over 59,049. So r ends up being, all right, so I'm going to try to use my graphing calculator to find the 5th root. And one way that you can use your calculator to find roots like that is you can use exponents. So if you have, for example, a square root of x, then that is the same thing as having x to the exponent 1/2. So if I want to do a 5th root, I can make that the same as using x to the 1/5. So that's what I'm going to do here. So I'm going to take that value, 1 over 59,049, and I'm going to put it to the exponent 1/5. And I get 0.111. Sorry, I didn't let you see what I've done. So I have 1 over 59,049 to the exponent of 1/5. I get 0.1111, which is equivalent to 1/9. So my common ratio is 1/9. So that tells me, or that's what I can use to go and figure out what my missing terms are. So if I have term 81, I can times that by 1/9, and I get 9 for the second term. Then I can take 9 and times it by 1/9, and I get 1. 1 times 1/9 is 1/9. And then 1/9 times 1/9 is 1 over 81. And then I could verify, and 1 over 81 times 1/9 would be 1 over 729. So those are the 4 terms I'm missing. All right. In this one, we have a situation where we do not know the first term or the common ratio. And so this is one where we're definitely going to need to use some serious problem-solving skills to solve for our unknown. So what we're going to do, first of all, is we're going to read the problem. There's 3 consecutive terms that are x plus 3, x, and x minus 5. Use the concept of common ratio to determine the value of x and the 3 terms. So that's all the information we're given. We don't actually know what the first term is. We just have it in terms of a variable. And so we have some work to do. What we do know is that this term divided by this term is equal to this term divided by that term. Because every time you take a ratio of the 2 terms, that gives you the common ratio. And if it is a geometric sequence, then we are multiplying by the same value to go to the next term. So I'm going to write that out. I have T2 divided by T1 is equal to T3 divided by T2, which is the common ratio. So now what I'm going to do is I'm going to substitute in the values for T1, T2, and T3 and see if I'm able to solve it somehow. So T2 is equal to x, T1 is x plus 3, T3 is x minus 5, and T2 is x. So what I'm going to do to solve this is I'm going to multiply these the diagonals. So I've got x squared, and then I have x plus 3 and x minus 5. I'm going to multiply this out using FOIL. So I get x squared is equal to x squared minus 2x minus 15. Then I'm going to simplify. So I'm going to move I'm going to subtract x squared from both sides. I get 0 equals negative 2x minus 15. Then I'm going to add 2x to both sides. And so x equals negative 15 divided by 2. So x is the value of this number here. So I haven't actually found the 3 terms yet, but now that I know x, I should be able to solve for what the 3 terms are. So term 1 is x plus 3, so that's negative 15 halves plus 3, which is equal to negative 9 halves. T2 is equal to x, which is negative 15 halves. T3 is equal to x minus 5, which is negative 15 halves minus 5, which equals negative 25 halves. So the three terms are negative 9 halves, negative 15 halves, and negative 25 halves. So those are our first three terms of that sequence. All right, and this is the last example for this lesson. The fourth term and the seventh term of a geometric sequence are negative 54 and 1458 respectively. We're asked to use a system of equations to determine the values of the first term and the common ratio. We're asked to determine the formula for the general term of the sequence. So I'm going to start out by making a couple of assumptions. I'm going to start out by subbing information in about term 4 and term 7. So term 4 is equal to a r to the 3, and it's equal to negative 54. So if you recall, a is the first term, r is the common ratio, and then we use n minus 1. So n minus 1 is 3 because n is 4 for the fourth term. And then on the seventh term, we have a r to the 6 equals 1458. So I have two equations. Now what I'm going to do here is I'm going to rearrange these two formulas so that they're in terms of a. So for this one, I'm going to have a equals negative 54 over r to the 3. And for this one, I'm going to have a equals 1458 over r to the 6. So all I've done is I've rewritten this formula in a different way. Same with this one here. So now what I see is I have them both in terms of a. I can set this equal to this, and I should be able to then solve for r. So I have negative 54 over r cubed equals 1458 over r to the 6. So now I should be able to solve this by doing some algebra. I'm going to cross multiply, so I have negative 54 r to the 6 equals 1458 r to the 3. Now what I'm going to do is I'm going to divide both sides by r to the 3. That leaves me with negative 54 r to the 3 equals 1458. Then I'm going to divide both sides by negative 54. 1458 divided by negative 54 is negative 27. Then I'm going to take the cube root of negative 27 to find r, which is negative 3. So that is the common ratio for this sequence. We're also asked to find the value of a, the first term. So now that I know r, I can substitute it back into one of my equations, and then I'll be able to solve for a. So I'm just going to use the first one, a r to the 3 equals negative 54. I'm going to put in negative 3 in the place of r. Negative 3 to the 3 is negative 27. And so a equals negative 54 divided by negative 27, which is 2. So my first term is 2. My common ratio is -3, and my general term is t to the n equals 2 times -3 to the n minus 1.